So we take a look here. You want to just get rid of, so we first must, okay? Sorry, I didn't leave you much room. Get rid of the fractions. Which we've kind of already done, right? So if I wanted to get rid of the fractions in this, I could multiply by, you could multiply by 6, yeah. You could, yeah. That'd be a good one. And that's a smart choice. Initially, I was thinking, okay, I kind of fell back on the fact, okay, well, I see two different fractions. I'll multiply by 3 here, and I'll multiply by 6 over here. But then 3 or 6 is a multiple of 3, right? So if I multiply by 6, it's going to cancel it, which you'll see in a sec, okay? All this is just turning something that looks ugly into something that we did yesterday that we can work with. That's it. Okay, so if you're okay with 1.5, 1.6, we're just going to switch this thing into something that we can recognize and work with. That's all. And we do that by multiplication to get rid of the fractions. That's all. If it's decimals, which you'll see at the bottom, again, it's just multiplication. Okay, so I like the suggestion of multiplying by 6. You have 3 pieces. Each one of them has to be multiplied by 6. Okay, so if I multiply 6x by 3 plus 2 times 6 is equal to 5 times 6 divided by 6. Magically, okay, the 6's drop out, right, from that side. So we're going to get 5 on the right, and then you're just doing math on the left, right? 6 divided by 3 is what? 2x plus 12 is equal to 5. That looks a lot nicer. That's something I can work with now, right? That's all we're doing. So now if I'm provided 2 of them, like down in the bottom, okay, I guess like, in thinking about this now, you might not even have to do this in 2 stages anymore, right? There's a smarter way to do it, and it's like, the smarter way is like this. If you pick something that's common between the 2 of them, you just multiply by that number. So for instance, if I look at this one here, sorry, I keep writing over top of it. If I look at that right there, what's the first common multiple that both 3 and 4 hit? 12. Okay? So if I multiply that entire thing by 12, okay, instead of doing it in 2 pieces, like, oh, I want to multiply this one by 4 and this one by 3 and this one by 4, right? Instead of doing them in multiple stages, if you recognize that 3 times 4 is 12, right, and you decide to multiply this entire thing, all 3 pieces, by 12, it gets rid of the fractions. For the reason you'll see here, if I go 12 times 4a divided by 3 minus 12b divided by 4 is equal to, what's 12 times 6? What is that? 10 times 6 is 60, right? And then another, how many? Hey? Yes? I'm just trying to do the quick math. I'm trying to give you guys a quick mental math lesson.
Yeah, I'm saying, you said 6 times 10 is 60.
Yeah.
Like 6 times 2 is 12.
Okay. How many 12s do we have? 12, or sorry, how many 6s do we have? Okay. So if I do it 10 times, that's 60, and then another, how many do I need? 2 more 6s, right? So 72. Right? Does that make sense, everybody? It's all sorts of different ways to do it. Okay. the goal is like if you were to go to like University of Waterloo and they're like go right into math, they don't allow calculators. It's all mental. Most of the time, like the math that you start getting into is all like you don't need. There's not a heavy reliance on calculators, but that's a thing. There's no calculators allowed at Waterloo, right? So now you guys can figure this out. 12 divided by 3 is a nice number. 12 divided by 4 is also a nice number, right? So what's that? 12 divided by 3 is 4 times 4a, which you could do in one step. Doesn't matter to me. Okay, but I'm just doing it just to show you guys. And then 12 divided by 4 is 3. 3b is equal to 72. So your final equation, I'm going to go down here and rewrite this because ultimately I got to solve it. I'm going to have my first equation. I'll do this one in black and then I'll do the next equation in red just so you guys can see exactly what's what, okay? Yeah, Coco.
72, does it say minus 3? Or
Minus 3.
so equals 72.
Oh, sorry, that's just an arrow. Sorry.
Oh, sorry.
Okay? That's just turning it, that's just like steps. Sorry. Trying to like work horizontally instead of vertically. Okay? So 4 times 4a is going to turn into 16a minus 3b equals 72. Okay? So again, all the work for that equation will be in black, and all the work for the second equation here is going to be in red. Okay? So, and the second one is nice because I only see one fraction there, so I just got to get rid of it. So if I multiply by 6, you're going to turn something into 5. It's going to be 6 times 5a divided by 6 plus 6b is equal to 13 times 6. What's another 6 on 72? Okay. We'll do it in the next step here. 6's cancel. Right? Now you got 5a plus 6b is equal to 78. Now we can write that down here. Here's your second equation. 5a plus 6b equals 78. Now you could do one of two things at this stage. Okay? The one of two things are the things that I showed you yesterday. You could either use substitution to solve this, or you could use elimination. I look at that and kind of think, okay, it's lined up for me already. It's going to be a little bit more work for me to isolate for a variable, right? So I don't necessarily want to use substitution at this question, right? I can simply just take the first one. Remember what elimination is trying to do? We're trying to get one of the variables to cancel. I notice if I take the first equation, the one in black, and I multiply it by 2, what happens to the negative 3? So you're going to get 32a minus 6b is equal to, what's 72 times 2? Okay, 144. Now, what's nice about this? What am I going to have to do here? This I guess is a little tricky. But it's just the game of keeping track of the signs. So you're going to add 2 and 3 together for the reason that if I go positive 6 plus negative 6, that's going to equal 0. And then the b's are going to cancel. It's not subtraction because if I go positive 6 minus negative 6, that's going to equal 12, which is not the point of what we're trying to do, right? So we've decided to add the two equations together. Okay, and then we're gonna yield a result once we do that. So 5a plus 32a is going to be 37a. Okay, and then we have positive 6b take away 6b is going to be plus 0b is equal to, what's 78 plus 44?
222.
Okay. Now from here, what do we have to do? The b's are gone. We shouldn't even, like, you could rewrite this without the b's, right? Because 0b is 0b. Like, 0 times anything, the 0 eats it. So you basically have 37a is equal to 222. So just give me a. So if I just divide both sides by 37, what's a equal to?
6.
That's nice. Oh, like, I wanted you guys to see, like, we took something that looked pretty ugly and we got a nice answer, right? Right? So we just got one more step, 2 more steps. Okay? You're just going to plug this value in to one of your equations. So what we can do, I'm going to pick the second one. 5 times 6 divided by 6 plus b equals 13. 6 is cancel. That's why I chose that equation. Okay? So then I get 5 plus b equals 13. So b is going to equal 13 minus 5. B is equal to what?
4.
Okay? Just be careful. You know, sometimes on the formative yesterday, when you guys were switching from y equals mx plus b to standard form, there was just a couple little sign errors. You just gotta be careful, okay? Don't forget the negative, or like if you bring something over, it's got to flip sign, okay? Flip over, I mean move to the other side of the equal sign. Now, one more step. The solution is always the point of intersection. That's the solution. So the point of intersection has to be stated in your answer. And I always do it in alphabetical order, like XY, AB, 6, 8. Okay? And that's it. We could check that. If I asked you to check it on the test, you could check it by plugging it into both equations and checking left side equals right side. Okay? That's more of a, to ask you to do that every single time is a little bit of a tedious exercise, right? But there is comfort in knowing that you are right when you check it. Okay? So if you have time, if you finish early, go back and check them. Okay? If you don't get left side equals right side, you better fix it. Okay? Everybody okay? Okay. So that, like, I'm showing you this because we're gonna run in, like, in word problems. You're gonna run it, especially like with money or something, right? Money has decimals, right? So if we try and like find the intersection point between like lines that represent financial things, they have decimals. So we need to know how to work with decimals in order to solve problems like that. Okay, make sense? So that's the next question. Okay. Now, strategically, nothing changes. Okay, we're just going to do the exact same thing here, except the numbers get bigger. Okay, so if you have decimals, what would happen in the first one? Okay, so we get two equations. What if I multiply the first one by 10? What's going to happen?
You cancel out the decimal.
Yeah, okay, so this is kind of like, yeah. Um, okay. Um, this is kind of like the opposite. So if you have decimals, you're like multiplying by factors of 10. That's kind of the opposite of multiplying by a number to get rid of a fraction, a strategic number. Okay. And all it's doing, I don't know if you guys got shown this or not. Like have you ever heard of scientific notation? Did you guys do that in grade 9? No?
It's not where you go like 10 times 8 to the
12 or something, right? And then it's a game of moving the decimal place around, right? That's all it is, right? So if you had something like 0. Well, we'll do it in this question and we'll discuss it. But if I multiply this by 10, you essentially take the decimal and move it to the right 1. That's how you multiply by, so you could confirm that using your calculator. If you typed in 0.2 times 10, the answer you're gonna get is gonna be, you're gonna move the decimal physically to the right 1 place, okay? If it's 100, you'd move it 2. If it's 1,000, you'd move it 3. If it's 10,000, you'd move it 4, okay? So again, I'm just trying to give you guys like a little bit of mental math strength. Okay, so you don't spend as much time typing things into a calculator that you could do like this, right? So something like, you guys can confirm this by typing this into your calculator, but 0.2, I'm gonna write these two equations 3 and 4, they're just gonna be scalar multiples again, okay? So number 3 is gonna be number 1 multiplied by 10, okay? 0.2 times 10 is going to be 2u. 0.5v multiplied by 10 is going to be 5v is equal to 4.6 times 10 is going to be 46. Okay? Okay? And then in the second one, I see 2 decimal places. So I'm just going to multiply by 100. Remember, the goal is just to kind of try and get some solid numbers there, right? Like whole numbers, no decimals, you know, numbers that we can like manipulate to do the elimination process. That's what we're after. Right? So if I do that, in the fourth one, we're going to get 3u minus 2v is equal to 12. Okay, a little tougher in the last question. Well, all of a sudden, I've taken something that looks pretty ugly and I've turned it into something that looks like what we did yesterday. At which point, it's now a question of whether or not you can do the work from yesterday. Okay, so we're just gonna like, you could do whatever you want. Do you want to do substitution? Do you want to do elimination? I did not specify in this, right? If I just say solve, you could choose either. It's whichever one you prefer to use, right? Unfortunately, for the purposes of the curriculum, I have to see that you can do both. So I have to specify in certain instances. Again, that's why I kind of like, I have one test to test you on like everything up to 1.6, because I can test you on substitution and elimination. But on all the word problems, I don't care how you solve the word problems. If you like elimination better, you can solve the word problems using elimination. Right? That's why I do 2 tests. Okay. Trying to figure things out in the first little bit and then apply it in the second test. Right? So I don't know. It might be a bit of a hassle to rearrange those things for one of the variables. Not to mention, once you do that, you're probably going to have some fractions to deal with. So I would just use elimination for this, right? So again, what variable do you want to get rid of? U or V?
I did U. Just multiply the top by 3 and the bottom.
Yeah, it honestly doesn't matter. You can get rid of U by doing what Rita said. You can go times 3 times 2. You could also get rid of v by multiplying number 3, the red equation, by 2, and the green one by 5. That's going to make these two guys be 10. Doesn't matter. You're going to get the same answer regardless if you do everything right, obviously. Okay, so let's just stick with that because the numbers are a bit smaller. Okay, so if I rewrote 3, like the red equation that multiplied by 3, I'm going to get 6u plus 10v is equal to, what's 46 times 2? 92?
46 times 3, you mean?
Oh, sorry, you're right. Sorry. What is it? I don't have the.
138.
Okay, thank you. Okay, and then in the bottom one, I'm just multiplying everything by 2. Yeah, by Lucas.
Yeah, it's supposed to be 50.
Sorry, yeah. I don't know why I multiplied by 2. Probably because the next one's 2. Good catch. So this is what I mean. Like, it's good. Sometimes I might play it off as if I've made a mistake on purpose, so that you guys know not to make mistakes. Sometimes, if I make too many of them, I might start playing it off on purpose. That's only number 1 today. Number 2, right? No, it's only number 1. If we get to 5, I'm going to start doing them on purpose. Okay, a second one. If I multiply 3u by 2, I'm going to get 6u minus 4v equals, what's 12 times 2? 24. Okay? Now we've done this on purpose, right? We tried to get 2 of the variables to be the same, or the coefficients, sorry. We talked about coefficients yesterday. They're now the same in front of u. So if I subtract these 2 equations, the u's are going to cancel out. 6u minus 6u is 0u. So 0u, 15, okay, here's a little tricky one. 15 minus negative 4, that's 15 plus 4. It's going to be 19. V is equal to, what's 138 minus 24? 114, okay? 138 minus 20 would be 118, minus another 4 would be 114. Okay? Again, just a little more mental math for you. Okay, just break things down. Okay? So now I have 19v is equal to 114. I can divide both sides by 19. And what do I get for v?
6.
Okay. What do I do with that? Does it matter? I have 6 equations on my page, right? Does it matter which of the 6 I plug it into? It doesn't. They're all, well, 3 of them match 3 of them, right? But it doesn't matter. You could plug it into any of those 6. You're going to pick the one that looks easiest for you. It's probably not 1 or 2, right? It could be 3. Maybe be 3, right? You want to deal with, or even 4, because 4's got smaller numbers, right?
I just said 3 because its subtraction is ugly. So.
Oh, true. Okay. Whatever. If subtraction's ugly to you, it might not be ugly to someone else, right? Doesn't matter. The point is, it doesn't matter, right? So you can plug it into anything. If we want to do 3, we can do 3. Okay. So plugging into 3, we can find u. Okay, so 3u minus 2 times 6. I'm doing 4. Doesn't matter. You want to do 3? Are you stuck on 3?
No, you do what you want.
Okay, let's plug it into 4. Okay, 3 times u minus 2 times 6 equals 12. 3u minus 12 equals 12. 3u is equal to 24. Remember what I'm doing. All I'm doing is just moving things. I'm going to add 12 to both sides now. And those drop out. 3u equals 24. What's 24 divided by 3? Okay. And then your final step to get you full marks is just stating the point of intersection. What comes first, u or v? I don't know.
You.
U. Okay. So we're going to go 8, 6. You know, something simple like that, if you guys ever mix up something simple, right? Which goes first if it's like X or Y, if you guys are plotting points, you always know it goes in alphabetical order. This happens all the time. You see it even like right up into the 3U course. People are mixing up, they go to graph an equation, and the Y and X are flipped. Right? Always alphabetical order. Okay? That's just maybe just good practice. I don't think there's a real rule with how the other variables are supposed to be written. Okay? Any questions? Okay.